Hello everyone. In this conversation, I want to showcase Galaxy different components of our system, how it works all together. We'll talk about Galaxy Desktop app, Galaxy Chrome extension, and our Galaxy Hub web application. But first, before I would like to talk about the reasons behind it, why we are viewing it. That is basically a statement that knowledge is a key to happiness in life. And to approach this statement, you can look from different angles to prove it. Whether you wake up in the morning and if you know the weather will be today, you can know which clothes to wear, you can be prepared for the day, or you work in financial institutions, and by having the right information, the right knowledge, you will ensure to make the right investments. In general, learning new skills is essential for happiness in life, as in no way any would say a pizza that you could get anywhere compared to pizza that you make yourself if you have the right skill. And this is why we constantly strive to learn, to explore, to build our knowledge. However, today the internet is very limiting to our ability in learning, such as we have on one side a very static databases of knowledge, such as Wikipedia. They are more like historical. They don't provide you with real-time knowledge that US we can obtain from social networks. However, social networks on their side are hijacking our natural curiosity to exploration. And what happens in social networks, you can compare it with this analogy in food that I recently discovered where you can compare calories and nutritional value. There are sometimes foods that provide a lot of calories, but not a lot of nutritional value, and the same happens with information that we discover in social networks. A lot of it can make you feel good in the moment discovering it, but does not really provide you any foundational blocks for building what I call is your personal knowledge tree. And this is what important. Building your personal knowledge tree, sharing it with others, and building the digital garden of the internet that facilitates efficient research on different complex topics together. And so we begin to approach our solution with the idea that we can utilize canvas to visualize fragments from different pages next to each other to show all of them at the same time. And so we use Excalibur, which is the most performant implementation on top of HTML canvas that as allows you to actually render thousands of images at the same time with high performance. And since performance is our focus here, we since also need a desktop app. We'll come to it later. And since we need performance, what are our options in or traditional ones using like Electron, using Tauri. However, their drawback is performance. They are both dependent on web UI, which cannot compare its performance to native browsers, canvas. Another important solution with device is actually to spawn browser. Whatever browser you have in your operational system installed, will spawn this browser for you and spawn Excalibur application inside it as a progressive web app. And inside of it, run inside of this front end, we run the library that connects to Galaxy server that runs on your machine and it can communicate with. And this is we come to reason why we need a desktop app because as running on your computer, it can have access to all your programs installed, all your CLI tools, and hence we can not only extract content from in the browser. You can do this fetch with HTTP, but here you can use any protocol to take data. You can take data from anywhere on your local database from any using any external IP plus other protocols. And you can aggregate all of it to put all of it on the shared canvas, to put it on the shared same canvas. And this is where things get really interesting. Let's look at the following five examples. First, here I put two images and I put text matryoshka.g. It means I create custom command when I write matryoshka, it's name of my knowledge layer. So when I can see actions to it, I press load and those two images attached to it are loaded. I move it, resize it down, and I press again. Those images are loaded again and adjusted its size. Now, repeat doing this. It's just demonstration of this very simple macros I did. Let's move to the next example. That is more interesting as you remember we can spawn, manipulate new windows and from inside of the canvas itself. So here I made application inside of Galaxy and integrated with this that OpenAI that resembles is better chat GPT using better chat GPT and embedded static files as it's inside of Galaxy. So when I write name of the chat, it spawns exactly the same chat where I stopped the conversation, so I continued side from there because connects to the same database. Next, we will try to spawn Galaxy new canvas from inside the canvas itself, such creating the nested whiteboards. So I will create a first layer and I'll make a link to a new layer inside of the spawning portal from this image. And this image, this new layer does not exist, so it spawns an empty window. But now when I select and I create a new portal from this layer previous to this parent itself, and when I save it when I press Command save it, and then I will jump back to the original layer, and it will open a new window again. So this way, I'm going to demonstrate I can create nested layers, nested whiteboards inside of nested whiteboards themselves, and those windows I can move around, all of them are synchronized and saved. Next, actually, I want to share my whiteboards with others. So for this, I'll create this layer. I will give it a name, upload it to IPFS, then we'll make transaction to Polkadot, Wallet, to actually claim ownership over this IPFS layer and give it a name. So I will can share it by link and other people can upload it to their layer by its name or a link. And actually, what's interesting, you can combine different layers inside of yours. So you can continue keep building layer upon layer upon layer. Next, we have this demonstration with Internet Computer, where you upload this photo gallery into the canister, and then it creates uh, after what's interesting, you will see it automatically creates a grid layout of those images. What it demonstrates how you can actually integrate external websites to convert them, those gallery, those websites, those separate pages, you can convert them into a grid view. And you can see all of those separate pages before, you can see all of them now on the shared canvas. So now the important question is, where do we go from here? What is the most efficient way to organize your knowledge would be personally, on local scale, and inside of organization on a huge scale and global scale of the internet. And here we draw inspiration from Git version management system, specifically from the way it works when you make changes to a file and you describe your changes in commit message. What it does, it actually takes copy of your file where you make changes and it persists the original file as it was. So anytime you can jump specifically to that commit to the original file or any point in your commit history. In our case, we don't work with files, but with elements on the canvas, which can be either an image, it can be a text directly, it can actually point to another file loaded as text. But here we work with elements. And what if you can actually track the history of every element the same way as you keep track of history of files inside of repository. So now when you save your canvas scene, what it actually does, it takes copy of every element on the canvas. It's actually very efficient with images because don't worry, there are always persisted only one image inside of the database. It never duplicates because actually the element, it points to it by the hash of the image. So what we do, we copy every element and we write a commit message when you say this thing. And anytime in the future, you can jump back to the specific element to see its history of changes. And you can do it for every element individually, not for the scene, for every element. You can do it individually to see history of its changes. You can see it as you normally see in Git client history, linear history, or with branching. Here you would be able to jump to some point changes instantly that you want to see. And now, how is it connected to previous example that I have shown where we have a grid, we have this grid of the images where you can see all of them. So when you jump inside, you expand, expand from this preview of the internal layer to its actual content. What we saw with example with Matryoshka, we just begin with text element, and when you press the button, it loads its content. So what we actually do here with this expansion and then shrinking back to the preview, when we do expansion of the element, we actually convert it, we generate grid view of all its versions that it represents. And actually, it will work interoperable with Git repositories itself. So when you open Git repository inside of a Galaxy to see your code base, you can see all of the files visually. You can move them around to see how they are interconnected. And then what we can do is to point to particular file and open this file in a new window. So when you click to open this file in a new window, you will see history of its changes side by side. So kind of Git blame, but this is kind of operation in GitHub where you can see the history of changes of particular file. But now you can visually see difference. You can instantly spot the difference between versions of this file because all of them are visualized next to each other. You can zoom out and literally move them around and see what is their comparison next to each other. And this is applies to books as well. So when you open a book, usually you see just one page in front of you, or like two pages when you open a book in front of you. So here we this current page in on this parent whiteboard. But when you want to see all of the pages, uh, to zoom out, to see overview of the book, to move around, to see what's interesting for you, click inside. So first you click on this page, on this book, and you will see on the sidebar its history in shape of history of its changes. You will actually see the list of the pages inside of the book. What we are doing here, we represent the book itself as its different pages, as stored as points of different commits inside of the book. So when you press on it, you see the history of the changes. But when you go inside of it, you spawn a new whiteboard. You see all of the pages at the same time. So you expand it. Again, when you shrink it, so you still can jump in between of the pages, but it's just showing us one page at a time inside of parent whiteboard. When you expand it, you see all of the pages at the same time. Then when you shrink, you can see the history of the history. It's like not really the history of changes, but in this case of the book, it's just list of its pages, whatever it is inside of it. So inside of file of Git, its history of its changes. Inside for case of book, it's actually different pages of it, and you choose which one of those is being displayed as preview on your parent whiteboard. So the same applies for, let's say, an article that you can read. In this case, you can separate it by sections, very flexible way. You can, as the same way as we did, you can build again it on multiple levels. So you can put your library inside of the library, it books, its book, inside of it book is chapters, inside of each chapter there are sections that you can expand and shrink to zoom in and zoom out. This is the very most efficient way to organize information, either on small scale and on huge scale. It works very well. And at this point, we have to reconsider our storage, our approach, how we store these things when you want to share them. Previously, we demonstrated how you can upload your whiteboard scenes to the IPFS or to ICP canisters. However, those solutions are not the most practical in terms of cost and speed efficiency, because what we need to think about here is the chunking strategy, how our sometimes huge scenes, sometimes they can be huge. There are a lot of images. Their size can be measured in gigabytes. So what IPFS does, it's doing chunking of the scene to very small chunks and attaches to every chunk, every fragment of our file. So it separates our big file into very small fragments, and it gives to every fragment its own hash. And then when you need to load this file back, it will do a lot of complex routing to find every fragment and then recollect together and then respond it to you. This is not most efficient. In case of internet computer, the size of the chunks to the upload to the canister is higher. However, it's still not the most practical. Even though in case of ICP, you have privacy assumed by default in terms of IPFS. You still have can do encryption in ICP. You have privacy assumed by default. However, it is still not the most practical solution. What is the most practical way to share your scene with others? Since it's already being stored, every scene being stored as a separate SQLite database file, which contains all the tables which keep track of the history of the elements. The most practical way to share it is simply upload it to the remote server and then configure the Galaxy server that will accept incoming requests and will respond with this scene. What Galaxy Server provides is also authentication over your, but you don't want to give it to everyone. Or perhaps you want to give it only to your inside of organization. So Galaxy Server can check the signature. When you upload it to public, you choose the minimal donation amount that he has made at least the minimal donation, and only then he can download the file into his local vault and open it and modify and build on top of it. So you have created the scene, you upload it to your server, and now how do others discover it? Of course, you can share the direct link, as we saw before, but only those people who already have Galaxy browser installed will be able to load it. And how do you see what is inside of it before you load? So this is where the important social part community comes in with Galaxy Hub. This is where people can collaborate, discover each other whiteboards, connect, make comments, and so on. And of course, most importantly, they can see each other contributions, who is building on top of each other floor, of each other whiteboards, fragments of it, and who makes the most donations to who supports over a long time different creators inside of the community. This is the essential component of our ecosystem. So when you open your scene on the Galaxy Hub, it will show you only a preview of it, and then you can press the button that will trigger deep link to open Galaxy browser on your desktop or download it if you don't have. and then it will download the SIM inside of Galaxy browser from your remote server. So you as creator of your SIM, you can specify inside of Galaxy Hub the URL of your server. So in difference from GitHub, where the SIMs are stored, where repositories are stored all on the same centralized server of GitHub. In our case, you as creator of the scene, you just specify the URL of the remote scene where the Galaxy browser will download it from. And you can also, you also choose if it's your server, or you can choose perhaps some mirror servers that can be used to download your scenes as well. And of course, you specify your donation amount, what we discussed before. This is the important component. This is the reason why people would donate more than you specify as minimum donation, because there will be a leaderboard of the biggest contributions and the contributors. This is the essential component of the healthy ecosystem where people can discover each other's work and contribute to each other's success. Finally, the last and the least developed component of the system so far, this is our browser extension. So, when you explore the internet, it often happens, and this is the whole point here, that you want to save something. Usually, you take a screenshot or you copy paste it to your notes. There are more advanced ways, such as Raindrop, that allows you to create collections. Actually, even Microsoft Edge browser allows you to create collections natively. It's different from bookmarks because it remembers the exact position that you highlighted on the page, similarly as you do with normal books, where you highlight something important with marker. The same applies here when you want to copy something into the Galaxy. Currently, you just take a screenshot or manually copy paste. How much convenient it will be when we have this extension where you can just select some text or piece of a page, and that's it. Will go into the Galaxy buffer where it will be waiting for you. So it goes specifically to the scene that you have chosen for taking those fragments that you are saving currently, and it will be there in waiting you in grid view. So from there you can move it to particular another whiteboard or keep it there. So either way, that fragment that appears in Galaxy Whiteboard now, it takes a screenshot of this area on the page that you chosen, and also along with the screenshot, it remembers the link to web page. So when you click on the image, it will spawn a new browser window the same way as we saw before in example with better ChatGPT where it was pointing to particular conversation. So here it will be pointing not just to URL, but it will also remember particular coordinate or selector of the element. So it will direct you, highlight specifically that area when you open it in a new window by clicking on the link. And otherwise, so you could just go through the page, highlight what you want, and it will just save those uh, piece by piece separate images into the grid view on specific whiteboards to provide you an overview where you can move it around and you can create this visualization like those fragments. This is how you create meta map of the internet. This is the essential process How you create the whiteboards, which you then publish and share to others. This is the process itself, and browser extension is crucial component of it as well. This is it so far, and thank you for your attention. Work with it.